Today we will see the working of p-channel depletion type MOSFET. But before moving towards the p-channel depletion type MOSFET, we will first see one small thing related to n-channel depletion type MOSFET, and the working of n-channel depletion type MOSFET we saw in the previous video. Okay, so let's see. In the n-channel depletion type MOSFET, we saw that our ID versus VDS curve, that is our output characteristic, look something like this. It is for VGS equals to 0, and if we make our VGS negative, the current decreases, so it will be somewhat like this. And if we make our VGS more negative, current will decrease even more, and there will be one VGS value for which our current will become 0. So this line, that is our x-axis, is for VGS equals to VT. And if we increase our VGS, that is if we make our VGS positive, current increases. If we make our VGS more positive, current will increase even more. So we can see here that when we increase the VGS, that is when we make the VGS positive, our current increases. Why current increases? Because the charge carriers in the channel gets increased. That is, the number of charge carriers in the channel get enhanced. So we can say that for our VGS positive, that is when our VGS is positive, our depletion type MOSFET is in enhanced mode. So for our positive VGS, our depletion type MOSFET is in enhanced mode. And why we use this enhanced word? Because the number of charge carriers in the channel got enhanced when VGS is positive. So now see, when VGS is negative, the number of charge carriers in the channel decreases. So we can say that our channel gets depleted of electrons or charge carriers when VGS is negative. So we can say that when VGS is negative, our MOSFET is in depletion mode. So this was that small thing which I wanted to discuss, that this is depletion type MOSFET curve. Even then it has enhanced mode in its output characteristic curve. Now let's move on to P channel depletion type MOSFET. So this is our structure of p-channel depletion type MOSFET. It will have n substrate, that is substrate will be made of n type material. Its source and drain will be of p plus type material, and its channel will be of p type material, that is it has p channel. And then there is the oxide layer, above that there is the metal layer, and then we have the gate terminal. Here we will have the drain terminal. Here we will have our source terminal, and here we will have our body terminal. Now since source is taken as reference, so it will be considered to be grounded, and since we are not considering the body effect here, so body will be sorted to the source, so it is also grounded here. Now our drain is of P plus type material, and our substrate is of N-type material. So we can say that here we can imagine a diode which will look like this, because we know that in a diode this is P side and this is N side. So since our drain is of P plus type material, so this side will be here, and since our substrate is of N type material, so this side will be here, N side. Now we know that for holes to move, we need some force, that is holes of the channel. To move, we need some force, and that force will come from electric field, and that electric field will be created by depletion region, and that depletion region will be created by reverse bias, and this reverse bias will be created by applying negative voltage at the drain, that is negative VDS, because our source is 0, so whatever VDS is, that will be equal to drain voltage. So here we can also say that negative VD. So for the holes of the channel to move, we need some force, and that force will be coming from electric field, and that electric field will be coming from depletion region, that electric field will be created by depletion region, and that depletion region will be created or increased by reverse bias, and that reverse bias will occur when our VDS will be negative. So here we can say that here we need to take negative voltage at the drain. So when we will take this negative voltage at the drain, what will happen? Here we will have a depletion region, and in depletion region we know that, first of all, we know that P-type material looks like this, negative ion paired with holes, negative ion paired with holes. So the drain is made up of P plus type material, so it will also look something like this. So these negative ions will come here, and substrate, that is substrate is made of N-type material, so N-type looks like this, positive ion paired with electrons. So these positive ions will be here, and due to these positive ions and these negative ions, our electric field will be created, and that electric field will look something like this, that is the direction of the electric field will be from here to here, because the direction of electric field is always from positive to negative. So here positive ions of N substrate and negative ions of drain. So electric field will be from here to here in this direction. Okay. Now because of these ions, our electric field is created. Now because of this electric field, the holes which are present in the channel, because channel is of P-type material, so we know that this is P-type. So in P-type we have holes as the charge carrier, because these ions are immobile, so we have only holes as the charge carrier. So holes from the channel will move in this direction, because we also know that holes move in the same direction of the electric field. Okay. Now, if we keep on increasing this drain voltage in negative direction, that is, if we make our drain more and more negative, what will happen? Then after some time, that is at a certain negative VDS, this channel will get depleted of holes, and so our current will become saturated So, two things happen when we increase the negative voltage at drain. That is, one thing is that our electric field will be become stronger. It will become more and more and more strong. But also this other thing will happen, that the channel will get depleted of holes. So our electric field is stronger, but there are very less holes in the channel. So a time will come when our channel will get so depleted of holes that our current will become saturated. After that, our current won't be able to increase even if our electric field is so strong. So our curve will look like this. That is output characteristic of P channel depletion type MOSFET. This is VDS and this is ID. So up to certain instant, that is up to certain value of negative VDS, our current will increase, but at a certain instant of VDS here, that is, we call it as VDS sat. Sat means saturation. At VDS sat, our current will stop increasing and it will become saturated. And this value of ID is also known as ID sat. And again, sat means saturation. That is saturated ID, and VDS sat means the value of VDS at which our ID becomes saturated. That is why it is named as VDS sat. So this is the output characteristic of P channel depletion type MOSFET. Now we will see what happens when we apply voltage at gate terminal. So for that, let us see first what happens when our VGS is positive. That means what? Our VG will be positive, because our Vs equals to 0. So when VG is positive, let's draw first. This is our channel and this is gate terminal. This is source terminal. This is negative, and this is our body terminal. It will also be grounded. Now this is our channel. So our channel is of p-type material, and p-type material looks like this. And here we have applied Vg positive. So here we will have plus sign. Plus sign indicates positive voltage. No, it is not ion. It is just indicating positive voltage. And here we have N substrate, and N substrate looks, N-type material looks like this. Now see, when we apply positive voltage at gate, this positive voltage repels those holes which are in the channel. So these holes will move towards the substrate, and this positive voltage will also attract the electrons of the N substrate. That is, these electrons from the substrate will move towards the channel. So these holes and these electrons will recombine together, and that will cause the channel to get depleted of holes. So we can write that VGS, that is positive VGS, causes depletion of holes in the channel, So when charge carriers got depleted in the channel, so our current will also decrease, because what is current? Current is the flow of charge carriers. If charge carrier got depleted, that means our current will also decrease. So on applying positive Vg, we can say that our current decreases. Okay. Now, what if not all holes got recombined with the electrons? Even if some holes are there in the channel, then let's see what happens. So this is our channel, this is our drain, this is our source, and source is of P plus and drain also is of P plus, and this channel is of P type material, so it will have this thing. Now since most of the holes are recombined with the electrons of the substrate, so we will just show the negative ions. And now suppose even if there are some holes left in the channel, what will happen? If a hole tries to move from source to drain side, this is source and this is drain, it won't be able to. Why this hole won't be able to go towards the drain side? Because there will be a strong electric field here from positive to negative side. Positive voltage, negative ions will create a strong electric field, and due to this electric field, these holes won't be able to move from here to here. Instead, they will just come like this, because we know that holes move in the same direction as electric field, and because this electric field is so strong that it won't allow any hole to go from source side to drain side. So even if any hole is there which wants to go from source to drain side, this electric field won't allow it to go from source to drain side. So after a certain positive Vg, that is, we can say that at a certain positive VGS, our ID will be 0. Okay. Now we will see what happens when we apply negative voltage at the gate. So if we apply negative voltage at the gate, what will happen? Let's see. This is drain, and drain is of negative voltage. Here we have source is grounded. Here we have negative ions with holes, because this is our drain channel, not drain, sorry. This is our channel, and channel is of P-type material. So we know that P-type material looks like this: negative ions with holes. Now here we have N substrate. So N substrate looks like this: positive ion paired with electrons, positive ion paired with electrons. And we also know that in N-type materials, we always show that it is like this, that positive ions paired with electrons, but we also know that it contains some holes. They are in minority carriers, so we don't show it. So here we will show some of the holes like this. Now, because this voltage is negative, so it will attract these minority holes from the substrate towards the channel. So these holes of the substrate will be attracted towards the channel, and the number of holes in the channel will increase. And due to this increase in the number of holes, our channel gets wider. So we can say that on applying negative VGS, number of holes in the channel increases. And let me remove this. And this makes the channel wider and this will lead to increasing current. Because if we see that the wider the water pipe is, more the flow. So here also we can say that wider the channel is, more current will flow through it. Okay. So on applying negative VGS, we saw that number of holes in the channel increases, and this makes the channel wider, and this will lead to increasing current. Now let's see the curve. So if we draw the curve of ID versus VGS, that is output current and input voltage. So this is transfer characteristic of p-channel depletion type MOSFET. Now there was a certain value of positive VGS at which our current became 0. So this is pinch off voltage, that is Vp, and after this Vp our current will increase if we move the VGS in the negative direction. So this is the transfer characteristic of p-channel depletion type MOSFET. Now so this is the complete working of p-channel depletion type MOSFET. We will see one thing related to depletion type MOSFET, that depletion type MOSFET can't be used for amplifier. Why it can't be used for amplifier? Because we saw that even when there was no applied VG or VGS, even then current was flowing on applying VDS. So here we can write that depletion type MOSFET can't be used for amplifier because here current flows even when VGS is 0, and here we know that our VGS is input voltage. So we can say that our output is not dependent on input. But for an amplifier, the most important thing is that our output should be dependent on the input. Then only we can amplify it. Because like we saw that VO, in the first video we saw that VO equals to K into Vm sin omega t and where Vi equals to Vm sin omega t. So we can say that V naught equals to K into Vi. So here output is dependent on input. So for an amplifier it is necessary that our output should be dependent on the input. But in depletion type MOSFET, here we can clearly see that our output is not dependent on input, because our current flows even when VGS is 0 and VGS is the input. That's why we can't use this for amplifier. So this is it for today, and in the next video we will discuss about the enhancement type MOSFET, and we will see its classification, like N channel enhancement type MOSFET and P channel enhancement type MOSFET. Thank you.